Dear students, very good morning. Today we are going to discuss about embedded file system in unit number 4, embedded operating system and modeling. So let's discuss one by one. First upon introduction to embedded file system. We have to know what is embedded file system. Is a file system specifically for designed to be used with embedded system, which are typically resource constrained. What it is constrained? It is constrained based on the resource such as microcontroller, single board computers and other embedded hardware. So students, you have to understand it is typically based on the resource constraint. Okay, so next one is embedded file system are optimized for efficient storage utilization. Okay, so mainly optimized for efficient storage utilization. A minimal memory footprint and fast access speeds are needed, making them suitable for device with limited resources. Okay, students, you have to understand very clearly here. Embedded file system are optimized for efficient storage utilization. So that's why we go for embedded file system. Okay, and minimal memory footprint. So what it is, minimal memory footprint? If minimum memory usage means the system speed will increase, that is the objective here. Okay, so these file system often employs techniques such as wear leveling or flash memory, compression, minimal metadata overhead to maximum performance and reliability in embedded environment. So in this diagram, we have three types of wear leveling. So a dynamic wear leveling, static wear leveling, a global wear leveling. So in dynamic wear leveling, it is in single die. So in static wear leveling, it is single die but free plus user data blocks. And global wear leveling over die. So these file system often employ techniques such as wear leveling or flash memory. So in this black diagram we can understand very clearly. So first input is given to the input devices and interfacing device driver circuits. So we have a power supply circuit and it is given to the application circuit. So this black maximum objective is this file system management. So we have a processor. For the processor we have a timer, program memory, parallel route, serial port, data memory, interrupt controller. All this plays a vital role to perform an embedded file system efficient manner. Okay, so why file systems are needed in embedded? Okay, so it is mainly for the data organization and storage and data persistence, efficient memory management, multi-file handling, interoperability and security and access control. These are the important thing. That's why we are going for embedded file system. Okay, so next one is requirement. What are the requirements are available here? Minimal footprint, wear leveling support, real-time performance, compatibility with the flash memory, power failure resources. In this diagram we can clearly understand scalability, reliability and performance plays a vital role. Okay, so the objective of the embedded file system is we have to use minimal footprint. So minimum usage of the system will increase the efficiency, resource usage and we are leveling support, real-time performance. Okay. Now we can go for the types of embedded file system. Okay, so what are the types of embedded file system? YAFFS, yet another flash file system. Yet another flash file system is a file system. It is an optimized file system for non-flash memory commonly used in embedded system. Okay, so it is a non-flash memory commonly used in embedded systems. I hope you understand. Yet another flash file system. Okay. So next one is the FAT system. FAT means file allocation table. So in this diagram we have a three different file allocation. One is the boot sector and another one is the file allocation table. It is communicated with the directory, and root directory is also available. FAT is widely used in file system, originally developed for floppy disk. So for floppy disk, this fat file system is developed and later adopted for use with the flash memory storage devices. Okay, so first one is the YET and another one is the fat file system. That means file allocation table. Okay students, now it's the time for activity. So in this diagram we have a crossword puzzles. Now work on this. Okay, I hope you enjoyed this activity. Okay, next one is the flash file system. So till now we discussed about two types. One is the 8 and another one is the fat file system. Next one is the flash. What is the importance of flash? Flash file systems are specialized file system designed specially for flash memory based storage device. I hope you understand what is flash memory based storage. Flash memory based storage means like USB, like that, such as NAND and NOR flash memory. Okay, so next one is the what are the challenges we faced? Limited resources. If file systems or embedded file systems is not available means what are the challenges we face? So it is a limited resource, and then flash memory wear, power failure resilience, after that real-time constraints, a small memory footprint, a fast boot times, and customization and configuration. So these are the challenges will occur if embedded file system is not available. So I hope you understand the basics of necessity of embedded file system. Okay, so next one is the power failure resilience. What is mean by power failure resilience? So here in this diagram we have a five intersectional point. One is the extreme event characterization, and another one is the component functionality analysis, and third one is the system performance evaluation, and fourth one is the system resilience assessment, fifth one is the system resilient enhancement. So these are the important points as available in power system resilience analysis. So power failure resilience refers to the capability of the system or component to withstand sudden power interruption or failures without losing data integrity or functionality. So this power failure resilience will plays a vital role. So it reference to the capability of the system or component to withstand sudden power interruption. Okay. So guys, now it's the time for assessment on embedded file system. First one, first question is which of the following is the key requirement of embedded file system? Okay, the second question is which file system is widely used in embedded Linux system, and what does your leveling in flash memory aim to achieve? Okay, so thank you students. I hope you understand embedded file system, and then what are the types of embedded file system, what are the challenges of embedded file system if not available, or specifically we have to define it. Okay, so thank you all, have a great day. Thank you.